Algebra 2, Lesson 75, Factorable Denominators and Sign Changes. This isn't a totally brand new concept, we're just using it in a different way. Before we've seen these problems with multiplication and division, and then now we're being given the command to add, or the operation to add. And what they mean by factorable denominators is we're going to have denominators that are either trinomials or factorable binomials that have the greatest common factor, and we're going to rewrite them in order to make our addition and subtraction easier. So when you see a problem like this, you're given the command to add, you have two fractions, and you see a trinomial in the denominator, immediately think factor. Remember, every time we see a trinomial, we should ask, hey, can I factor that? It makes things a lot easier. So we'll start by trying to factor this denominator. The first term is x squared, so I know each of these is just going to be x. Both signs are positive. So, well, the last sign is positive, which means I know both these signs are going to be the same. And the middle sign is positive, which tells me they're both going to be positives. Now I need to find a number that multiplies to 1 but adds to 2, which is kind of funny because 1 times 1 will equal 1, but if you add 1 and 1, you get 2. So this is going to be x plus 1, x plus 1. Now, when we look at this other denominator, this one's a little bit tricky. This doesn't look like it can be factored. It actually can. It actually can. The greatest common denominator here is -1, and that's something you should look out for. If you see a denominator where both the terms are negative, you can actually make it positive by factoring out -1. So if we factor out -1, this will, and I'll rewrite it in descending order. If I divide -x by -1, I get positive x. If I divide -1 by -1, I get positive 1. So this becomes -1 x plus 1. Now, you might be asking, what am I going to do with this -1? It's really simple. I'm going to combine it with the sign out in front and change the sign. So, after we've done our factoring step, let's go ahead and rewrite our problem. So it's one of our favorite things to do. Our numerator here is not going to change. It will remain x plus 7. The denominator is now x plus 1, x plus 1. And here is where that sign change comes into play. Since I've got this -1 here, I'm going to combine it with that sign. The negatives cancel to make this positive. This numerator will stay the same as 3, and the denominator is now x plus 1. Now, what that does for me is it makes it easier to add these because I don't have to work as hard to find a common denominator. Whereas before, if I had -x minus 1, that seems like a different number. I would have to try to find a common denominator by using 3 terms instead of 2. Here I can see the common denominator is just going to be x plus 1 times x plus 1, so I multiply this second fraction by a value of 1 written as such. What that does to this numerator changes this one to become 3x plus 3. 3x plus 3. And then the denominator just becomes the same as this. So what we now have is x plus 7 plus 3x plus 3 all over, parentheses, x plus 1, x plus 1. Here I can add like terms, x plus 3x, we'll do this in a different color, add like terms, and x plus 3x becomes 4x, 7 plus 3 becomes 10. So I have 4x plus 10 over x plus 1, parentheses, x plus 1. And that is my final answer. So it's not too difficult once we factor it. I'll go ahead and do one more example. If you think you've got it, you can go ahead and start your lesson. If you need a little bit more help, we'll do one more example. Okay, next example. We're given the command to add again, and we see a trinomial in the denominator. So first thing we're going to think is, can I factor that? So, first term is just x squared, so go ahead and, what am I doing that for? X and x. The last term is a negative, which means both these signs are going to be different. And then I need to find something that will multiply to 15, but add to -2. For me, that answer is going to be -5 and +3. 3 times -5, -15, -5 plus 3, -2. Cool. So we got the first one. Again, the second one, we notice that we have 5 minus x. This goes against the previous problem where we had x in the beginning, and here we had minus x again. So your key here on these denominators is if you see minus x, you might want to think, I should change that. So we'll do the same trick, factoring -1 out. And when I divide negative x by -1, that becomes a positive x. 5 divided by -1 becomes -5. All right, and then again, we see we've got a matching term on either side. So you really have to get good at using this -1 trick and spotting these denominators where you can use this division by -1 or this factoring of -1 to rewrite it. So from here, we'll go ahead and rewrite our problem. Our numerator for the first term is going to remain the same. We have x minus 3. The denominator is now x plus 3 times x minus 5 in parentheses. This sign is going to change again, except this time from it going to negative to a positive, it's going to go from a positive to a negative. So now we have minus x plus 2. And then we have the denominator of x minus 5. And mentally, it's always a good thing to try and insert parentheses around any polynomials in fractions. A reason for that is because of this negative, the way this negative is going to get applied. And we'll see that in a second. Not going to do it yet, but we will see it in a moment. So now let's go ahead and find our common denominator, which means we're going to have to multiply this right side by x plus 3. So we multiply x plus 3 on the numerator and the denominator, which is just the number 1. That's going to make the denominator x plus 3 times parentheses x minus 5. Now for the numerator, what that's going to do is we're going to have to FOIL. So when we do x and x, we get x squared. X and plus 3 gives me plus 3x. 2 and x gives me plus 2x. And then 2 and 3 gives me plus 6. I will combine these terms, so that becomes 6x. So now I have x squared plus 6x plus 6, but in front of this numerator I have this negative. And if I'm going to write both of these numerators on the same line, like I want to down here, then this negative needs to get applied to this numerator. And what this negative is going to do is it's going to distribute to all 3 of these terms. So what this becomes now is negative x squared, negative 6x, and negative 6 down here. So this negative changes the signs of all 3 of these in the numerator. So we really have to be careful with our negatives on these problems. The first numerator will stay the same. It's just going to become x minus 3, and those parentheses don't apply because there's no negative sign in front of it. So from here, all I'm going to do is combine like terms and then write my final answer. So like terms are going to be x and negative 6x. The numerator is going to start off with negative x squared. That one's not going to change. X minus 6x is going to become negative 5x. And then 3 minus 9 is going to become, negative 3 minus 6 is going to become negative 9. And then our denominator is going to become x minus 5, parentheses, x plus 3. And, I just realized I made a mistake. I went to check my answer and I realized I made a mistake. All the way back up here. 3 plus 2 is not 6. 3 plus 2 is 5. So that in turn should be negative 5. And then 1 plus negative 5 should in turn become negative 4. So with the exception of that one number, this is the correct answer. Negative x squared minus 4x minus 9 all over x minus 5, x plus 3. All right, that's it for this lesson. If you have any questions, let me know on Moodle, and I will see you in class.